We want to evaluate the square root of 2i. When you are evaluating square root of complex numbers, just equate that complex number to a plus bi. Now, at this point, I don't have a choice but to remove the root. For me to be able to remove the root, I'm going to square both sides. And don't square this side individually. So this square root and the square cancels, we're going to remain with a 2i. And when we expand this, we are going to get a squared plus 2abi plus bi squared. The question is, how have we gotten that? You can write it twice, a plus bi multiplied by a plus bi. So multiply a by a, that is going to give us a squared. Multiply a by bi, that is going to give us a bi. Multiply bi by a, that is going to give us a bi. And then multiply bi by bi, that is going to give us bi squared. So it is this one, abi plus abi, that has given us 2abi. So from here we have got 2i being equal to a squared plus 2abi plus, I can expand now. Here we're going to have b squared I squared. Now I squared is a negative 1, so that means this is going to become negative b squared, and that will become a real number. And let's put like terms together. So I squared minus b squared, we're going to put them together because they are real numbers. And then we have got the imaginary part, which is here, the 2abi. So this is the real part of this complex number. This is the imaginary part. We're going to compare now the left hand side with the right hand side. We can see that this side we don't have a real number, a real part. That means the real part is 0. So we're going to equate the real part to the real part, the imaginary part to the imaginary part. So that is now what gives us a squared minus b squared being equal to 0. And then here we are also not getting the i's because they are the same. We're just getting the coefficients. So 2ab is equal to 2. Divide both sides by 2. That will give us ab being equal to 1. Make any of them, either a or b, subject to the formula. So if we make a, we are going to have 1 over b. If we get this now, we're going to come in this equation. Where there is a, we are going to put 1 over b. So this one, if I expand now, we're going to have 1 over b squared minus b squared being equal to 0. Now when you want to solve this equation here, I'm going to say where there is b squared, we can let any number. So let's say let y be equal to b squared. So where there is b squared, this will become 1 over b squared minus b squared is equal to 0. Okay, I've just gotten this one, you can see here. Now where there is b squared, I'm going to put y. So 1 over y minus y is equal to 0. At this point, I don't want to do with a fraction. The best you can do is the same thing that is in the fraction, multiply the whole function with that same thing. So 1 over y times y, you are just going to remain with 1 because the y and the y, they'll cancel out there. And then minus y times y, that is going to be a y squared. That will be equal to 0 times y is still 0. I'll take the y squared this side, so we're going to have 1 is equal to y squared, which is the same as y squared is equal to 1. Meaning that, let's find the value for y, square root both sides. So y is going to give us positive or negative 1. We are not interested in y. Remember, y was just representing a b. So we're going to go back. I can remove this one. Please keep this equation, which is here, a is equal to 1 over b. So we'll get back to here, but b squared is equal to y. We say b squared is equal to 1 or b squared is equal to -1. It's from here because we found 1 or -1. We know that we cannot solve this equation. Why? Because if you say b squared is equal to -1, we can solve it because we're on complex numbers anyway. So for this one, we are going to square root both sides. Now, because this one, imagine, just take it that we are dealing with real numbers, we can't solve this part because we're going to square root both sides and we don't know the square root of -1, so forget about this one. Then we remain with this one, square root both sides. This is going to give you b being equal to +1 or b being equal to -1. We found b. Now let's find a. We got back to the equation. A was equal to 1 over b. So this means that when when b, we are dealing with b here, when b is equal to +1, what will be the value for a? A is going to be equal to 1. Where there is b, we put also 1 over 1, meaning that a is going to be equal to 1. And then what of when b is equal to -1? What will be a? A is going to be 1 over -1, meaning that a is going to be equal to -1. Therefore, we'll now go back to where we started from. We said square root of 2i is equal to a plus bi. But what is a? When a is 1, even b is going to be equal to 1. So we'll put a1 here, we'll put b1 there. So that will be 1 plus I. Or square root of 2i is going to be, when a is -1, b is also going to be -1. So substitute here. So that will give us -1 minus I. So these are the two answers. These are the two square roots of 2i. So the square root of 2i is 1 plus I or -1 minus I.